Good afternoon, dear colleagues. I want to give you a short overview of the decommissioning project of Thetis at the University of Ghent. I will start with a glossary, and afterwards the Thetis reactor will be described and its location. I will discuss with you the role of SEK in the project, the removal of the spent fuel, and also the dismantling operations. And finally, the declassification and some perspectives for the future. What would you do when you have an old nuclear power reactor or a nuclear reactor? Would you search on the internet like Homer? I don't think that you will get much of information about it, surely not to complete a total decommissioning project to decommissioning. So, to give you some explanation on the terminology in decommissioning, everybody knows that the nuclear installations are subdivided in classes. And they are well described in the Royal Decree of 2001. So we have three classes. One of them is the class 1, where the Thetis reactor was put in because it's a nuclear reactor. So what's actually decommissioning? Decommissioning are all administrative and technical actions taken to allow the removal of regulatory control. So when we have the removal of the regulatory control, we have declassification. Dismantling is not the same thing as decommissioning. Dismantling is only a small part of the decommissioning project. There are several strategies in decommissioning: the direct dismantling, the deferred dismantling, and the entombment. Direct dismantling is chosen for the Thetis project. So the direct dismantling is the dismantling within a few years after shutdown. The actual goal of the decommissioning is brownfield or greenfield. For the Thetis facility, we used the brownfield because the university wanted to reuse the buildings after all radioactivity was removed. The site is located in Ghent, in the southern part of Ghent, at the site INW, the Institute for Nuclear Sciences. To give you some more familiar viewpoints, I have put some pictures of the Ghent, just to show you how close the installation was nearby the city center of a big city. The INW site had several installations. First of all, the Thetis site, but we have also a neutron generator, a cyclotron, and 2 linear accelerators. All of these installations were shut down and are awaiting their decommissioning. Taking a closer look to the Thetis facility, you see that it's a rather small building with some laboratories on top. You have the reactor core in the middle of the building, surrounded by the purification and cooling circuit, and also a system for pneumatic transport of samples into the reactor core. The reactor was in operation since 1967. It was finally shut down in 2003. The reactor core contained 25 fuel elements of the low enriched uranium type. It was a light water reactor and it was graphite moderated. The power was 150 kilowatts. It was an open pool reactor. The pool diameter was 3 meters and the depth was 7.5 meters. And the main use of this reactor was activation analysis and the fabrication of radioisotopes for medical application. The figure below shows you the difference in dimension between the Thetis reactor, the BR3 reactor, and a commercial nuclear power plant like Doel 3. Taking a closer look to the build-up of the reactor core, you see here the 8 graphite blocks as a moderator. You see the tubes for the pneumatic transport, the control plates and safety plates surrounding the reactor core, and of course the reactor core with its 25 fuel elements. What was the role of SEK in this whole project? Of course, SEK had built up a broad experience on dismantling techniques and dismantling decontamination techniques. So in each step of the decommissioning of the Thetis project, we could assist the University of Ghent in their project. So SEK was actually a very good partner for the university to help them in their decommissioning project. For the evacuation of the spent fuel, we had, for example, the leak tightness test of the BR3 fuel and the organization of the transports. In preparation for dismantling, we could help them with all necessary documents for the license of decommissioning. Also the acceptance file for the radioactive waste to NIRAS ANDRAF, we could help them. And of course the dismantling operation. We had tested lots of dismantling techniques at the BR3 facility. We had developed a material database which is also has been used in the Thetis project. We had a quality system, and we had lots of experience in characterization of concrete. So the first step in the decommissioning project was the evacuation of the spent fuel. About 26 elements had to be removed out of the reactor core and shipped to Belgium process. The contact dose rate of a fuel element was about 1.5 sievert per hour in the midplane. It was an exotic spent fuel. It was no standard fuel, and there is a small amount. Therefore, the fuel was declared as radioactive waste. There was no documentation available. The plans were not as built. And also, no information could be gathered at the staff because all staff was retired. The main problem was the uncertain condition of the spent fuel, because all the fuel was still in its original position, the fuel that never left the reactor core. And of course, the first step of each project is the hardest one. The forklift, which had to remove the containers, the transport containers from the site, hit a bridge. So we started with 1 week in delay. The different pictures give you an overview of the total operation of the removal. The first picture gives you the sipping test and the visual inspection. Afterwards, the fuel assembly was transferred to the transport container. The transport container was tested for leak tightness for transport, and then was put on a truck to ship to Belgium process. At the Belgium process site, the fuel assembly was unloaded in the Pamela hot cell facility. There, the top and the bottom was cut off to fit in a 400-liter drum. We put 4 fuel assemblies per 400-liter drum, and the drum was cemented, and the fuel was stored at the Belgium process as radioactive waste. To go more in detail in the leak tightness technique we applied, at the BR3 we applied the wet sipping technique. So when a fuel rod is heated up to about 10 degrees, when we have a defect in that fuel rod, we will release some fission products. One of them is the cesium-137, and it's very good soluble in water. So if we put the fuel assembly in a sipping bottle, we can take a sample of this bottle and we can detect if the fuel assembly is leaking. We have applied the same technique at the Thetis facility, but we have guided us to the hydrostatic pressure. So when we take a fuel assembly outside the reactor core and we lift it 5 meters, there is a drop in hydrostatic pressure around the fuel assembly, so we get the same effect of release of fission products in that area. So every fuel element was tested before it was shipped to Belgo process. After the removal of the spent fuel, the next step was the dismantling operation of the highly activated parts in the reactor core, the pneumatic transport system, the control and safety plates, the graphite blocks, and also the total structure of the core. The reactor blocks were not cut and were evacuated as such to Belgo process. The other parts were cut with a hydraulic scissor. The cut pieces were collected in shielded containers. So the whole operation was remotely controlled. No manual operations had to be done by the operators. After removal of the high activated parts, we could remove the pool water and start with the decontamination of the pool liner. The water was removed to a truck of Transnubel and was evacuated as slightly contaminated water to Belgo process. The liner was decontaminated manually, by hand, and checked by the health physics of Ghent. In parallel, other auxiliary equipment was dismantled. You see some pictures before and after the dismantling. These installations were cut and dismounted to fit into 200-liter drums and were evacuated to Belgo process as radioactive waste. During the preparation of the project, we did some calculations about activation, and these calculations showed that no activation would be present during in the reactor pit. So after the cleaning operation of the liner, we measured some dose rates, so we knew that there was activation of the lower part of the reactor pit. Therefore, we launched a sampling and measurement campaign. We did some direct measurements on the lining and some core drillings in the concrete bottom plate. Based on these results, we removed the liner for a height of about 1.8 meters, and the concrete bottom plate we let them for a decay storage. So for next step in the whole decommissioning project was the unconditional release of the building. For this, we applied the flow sheet on the left and the German DIN norm as a guideline. So based on historical data and measurements and the nuclide vector, we put in place an initial categorization of each room of the building. We corrected this categorization by measurements during and after dismantling. The categories are from 1 to 4. 1 is that we were sure that there was contamination, and 4 that we were sure there was no contamination. This map gives you an idea of how each room has a category. We had the yellow category was number 3, where contamination was unlikely. We had 2 places where contamination would be possible, and also some places where no contamination was expected. Based on this categorization, we did the final characterization. And the number of samples was determined by the category and the item in the room. All this information was gathered in a document, and this document was approved by the Belgian authorities. We had the royal decree, which was published in November 2015. So we had the first declassification in Belgium of a Class 1 facility. The activated bottom plate was in place, and there was a decay storage applied. This was licensed under the overall license of the ENW site. Coming to the planning of the project, the original planning foresaw that we had to end at 2014 with the declassification. Unfortunately, we had 1 year extra. The main reason for this was that for the activation of the lower part of the pit and the asbestos inventory, which was not was largely underestimated at the beginning of the project. Some perspectives for the future. I've shown you in the beginning the other installations which are still present at the ENW site, the cyclotron, the linear accelerators, and the neutron generator. There are also some laboratories, and we hope to have the same cooperation with the University of Ghent in order to have the same decommissioning project for these installations. As a conclusion, I want to mention 3 points. The Thetis is indeed the first declassified nuclear reactor in Belgium. The management of the Thetis decommissioning was successfully executed by the SEKS CON specialists, and the know-how and experience gained during the dismantling of the BR3 reactor is applied in the Thetis decommissioning project. Thank you.